Solution to the first problem. If p x equals k represents a probability mass function, we can get this equation equals to 1. We can mark this equation one equation, and then we can multiply p at both sides of this equation, and then we can mark this equation 2. Then we use equation 1 minus equation 2 and get this equation, and we can find 1 minus p as n equals this. And if n is to infinite and p is between 0 and 1, we can know that p to the n equals 0. So we can find that Sn equals this equation equals to 1, and then we can get p equals to 1 minus p to the p minus 1 minus p squared. Then if we want to know Ex, we should get this equation. Same solution as a problem, so we can multiply p at both sides of the equation, and then we use equation 1 minus equation 2. Then we can get this equation, and we use this solution twice, multiply p at the both sides of equation. We can get equation 3. Then we use equation 2 to minus equation 3. We can get this equation. Same to a, if n is to infinite, we can get p to the n equals to 0. So we can get Sn equals to this, and we can get Ex equals to 1 plus p over 1 minus p. C problem, we use the same solution as B. So we multiply p at the both sides of the equation, and we can get this position. We can know that we can find that this equation can divide it into 3 parts, and we can fix it by fix each part of the equation. So we can get Sn equals to this, and you can get Ex squared equals to this. To the D problem, we can directly use X squared minus E squared x. And the E problem, when p equals 1 out of 3, we can know that p x equals k equals to 2 over 3 squared equals 4 over 9. And we can get that p x equals k equals to 4 over 9 k p k minus p to the k minus 1. So you can get when p is between when k is between 2 and 5, we can get this equation equals to this, and we can find the condition probability of xk when x between 2 and 5 equals to this, and we solve the problem.